Okay. Theory. Live. Nancy, if you're watching this, could you do me a favor and join my Zoom meeting? Because I don't have anyone in the Zoom meeting with me, and so it's going to time out after 30 minutes and then kill the whole Zoom meeting and crash it. So if you could do that, and then I'll let you in, that would be awesome. Or Chad, or both, whatever. And then just mute yourself, if that makes sense. Yes, I will record locally. And do you want me to record the audio as well, Chad, or just the video through OBS? Yeah, the normal link, Nancy. We'll probably do this every week. So let me know if that's working. How's it going, everybody? All recording. Record all the things. Okay, fine. All right, I'll record the audio separately, and then I'll record the video. But I wonder if the synchronization, if it is dropping frames. We'll see what happens. Double D, you're asking about the Hycean exoplanets. I've actually got someone coming on next week, the person who posted the paper, and he's going to be talking about it. So, done. All right, so I'm recording audio. Recording video. Okay. Let's see. Well, just want to focus on me. All right. Okay, good. And then you can just mute yourself and just hide the window. You don't have to listen to the audio from the Zoom meeting as well, Nancy. And that'll just prevent it from crashing my Zoom meeting after 30 minutes. Timing out my Zoom meeting after 30 minutes. Thank you so much. Okay. Awesome. Okay. I've got 2 questions in advance that I'll get to, and then we'll go into the actual live show. And I see a bunch of really great questions. I'm really looking forward to your questions. So, yeah, this background, is it too much? I don't know if it's too much, but I guess when Chad is putting in different, putting in all kinds of B-roll and stuff, it'll hide. But yeah, it was a new picture released from the Hubble Space Telescope, and it's a globular cluster. And of course, I love globular clusters, so how could I resist this? Okay. I'm going to host a Hycean planet. Yeah, right here in the house. Okay. So I'm recording the audio, recording the video. Let's get into it. Yes, I am recording, Chad. All right. Hey, everybody. Welcome to the question show. Your questions, my answers. As always, wherever you are, if a question pops into your brain, just write it down. I will gather them up and I will answer them here. Maybe it's because I'm just coming back from the hiatus, but there hasn't been a lot of great questions that have been accumulating in between the shows. So now's your chance. I'm looking for good questions. If something pops in your brain, write it down, gather them up, and we'll answer them here. And of course, if you want to join the live show, I do this every Monday at 5 p.m. Pacific on my YouTube channel. And so you can join live, and we do a bunch of live questions as well. So, all right, let's get into this week's questions. Still getting, so you've got the, did it come up on the on the screen? Okay, I closed it. I'll do the intro again then if it was up there for part of it. All right. That's weird that I saw it on my screen. That's really weird. Okay, all right, here we go. It's the question show time. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down on any video. I see them all. I'll gather them up and I'll answer them here. And maybe it's just because we're getting back from the hiatus, getting things back up to speed, but there weren't a lot of questions for me to gather up this time. So now's your chance. We've got a hole in the question continuity continuum. So definitely throw your questions in and I will gather a bunch of them up. All right. Of course, if you want to join the show live, I do this every Monday at 5 p.m. Pacific on my YouTube channel. And so we can have more of a back and forth conversation as well. All right, let's get into the questions. Okay. Don Carlo Di Vargas. Question: to build space stations, etc. in space, we must send it up with typical rockets. Is it possible to instead create matter up in space from the sun's rays, from the sun, making atoms from photons somehow? That is some Star Trek technology that you are proposing. And 2 months ago, I would have said no, absolutely not. There is no way that we know to turn just light into matter. We know of ways that you can turn energy into matter. Like if you take particles, you put them in a particle accelerator, you accelerate them up to enormous velocities, you're essentially dumping energy. You're increasing the kinetic energy of those particles, and you can increase them by so much that when they collide, the energy that's released is in such a compact space that particles dump out, and you get essentially energy getting turned into matter, but a very expensive way. I mean, you've got to spend an enormous amount of energy to accelerate these particles. But just in the last couple of months, researchers announced that they have been able to essentially force light into a very small area and generate particles coming out of it, essentially turning light into particles, creating a replicator. Now, of course, this is like a tiny little proof of concept that it is maybe possible to turn light into particles, and it's going to take a long time before anyone turns this into anything actually functional, like decades, centuries. So, but you're exactly right that lifting material off Earth to send it up into space to be able to use in space is very expensive. I mean, we're looking at least $3,000 a kilogram to $10,000 a kilogram, maybe even more. If you want to send stuff to the moon, you're looking at millions of dollars a kilogram. It's very expensive. Now, you don't need to turn the sun's light into atoms. You just grab stuff that's already in space. There are asteroids, comets, there's moon rock. There's all kinds of stuff that's already out there in space. And in fact, there's a whole science called in situ resource utilization. And this is this idea of wherever you are, if you're on Mars and you need to make fuel, turn carbon dioxide and water into methane, and now you can fuel your rocket. If you're on the moon, dig into a lunar crater and gather some of that water and turn that into oxygen, water for drinking, rocket fuel, things like that. If you're on the moon, grind up the lunar regolith and turn it into concrete and other building materials. So we're going to see really, and this is going to be the thing that enables our expansion into the entire solar system, is our ability to live off the land, to be able to go to some place, the moon, Mars, asteroids, comets, the outer solar system, whatever, gather up the local material that we need in that place and be able to create it and use it. So that is the whole future of space exploration from this point forward. And we're just at the nascent stages of this. So not photons into matter, but definitely using material out in space for stuff in space and not bringing it up from Earth. Oh, did it again. So you're seeing it again, right? I don't see it. Tell me, is that or did it just disappear again? Weird. Okay. Let me know if it returns. Steve Blandmag. When I see the artistic representations of what these Dyson spheres look like, all I can think is, where the hell are you going to get all this usable material? Should I say bleep hell? That's fine. Do this again. Steve Blandmag. When I see the artistic representations of what these Dyson spheres look like, all I can think is, where are you going to get all of this usable material? And by the way, what material would that be? How are we going to process it? How are we going to assemble it in the environment of the sun? Each of these questions has multiple tangents on their own. I think the romanticism of the Dyson sphere is getting out of hand. Also, how are we going to safely transfer the energy to Earth? Or are we? All right, Steve, slow down. Slow down. I think you are definitely getting away from yourself here. It can be as simple. You know, I've used this example many times already. We are already beginning the construction of our Dyson sphere. When you think of, say, the Hubble Space Telescope, or maybe the SOHO telescope, something that is in orbit around the sun. It is a piece of metal that was launched from Earth. It has solar panels. It is harvesting some of the solar energy coming from the sun, and it is turning it into some purpose. In this case, a telescope that is observing the sun. But then we've got lots of other stuff. You're going to have James Webb. You're going to have all the Starlink satellites. In the future, year after year, we're just going to have another spacecraft orbiting the sun, and then another spacecraft orbiting the sun, and then maybe somebody's going to build some kilometer-sized solar panel array to build some manufacturing facility to be able to generate that rocket fuel that I was talking about earlier. And just over time, we will build more and more satellites that will be orbiting the sun in various orbits. And so you can imagine some future time when we've used up all of the asteroids and turned them into satellites, sun satellites. And then we've, say, ground up the Mars and Mercury and turned them into satellites. And then we use up all of the moons of all of the gas planets. And then eventually we tear apart the gas planets themselves and build them into even more satellites that are orbiting the sun. And of course, each step requires more capability, more technology, and so on. But it is just this smooth step-by-step operation. It's kind of like saying, like, build New York City. Are you crazy? Think about how big that is. How many people would you have to move? And yet the city appears year by year as human beings set about building it. And so it's the same thing with the Dyson sphere. Now, if you took all of the planets in the solar system, all of the asteroids, all of the comets, all of the Kuiper Belt objects, and you just spread them out, you would be able to build a complete sphere around the sun at the distance of the Earth that was about 4 inches thick. So it's definitely, obviously we don't know anything that is strong enough to build a sphere. And of course, Dyson never said that people were going to actually build a rigid sphere. His understanding was that we would have satellites that were orbiting around the star, collecting the light in various ways on different orbits until you got to a point that every photon that was coming out of the sun was hitting some piece of hardware that we had created. And that would be the point where we were harvesting all of the power of the sun. And of course, it's a thought experiment. It's not like a real thing, a real engineering challenge. It's just, again, this idea of saying, if our energy use continues, what would be the logical end of that energy use? And it would be us surrounding the star in solar collection that we would then use for our future energy needs. Obviously, we can run out of power. Obviously, we can have something that sets us back. Obviously, we can end up being more, sort of not use as much energy, more conservation. Our population go down. We can get hit by an asteroid. There's a million things that will change that. But if you just look at the smooth curve of energy growth throughout the entire of human history, at some point, and not long in the future, our energy demands will match the output of the star. Clearly, this is like back when we had the Fermi paradox argument. So we're just going to have like an ongoing discussion week after week talking about Dyson spheres, which is fine. I'm up for it. All right. So let's see. John Cephal asks, any thoughts about the paper that suggests a meteorite destroyed an ancient biblical city? We reported on it in Universe Today, but there's like definitely a skeptical backlash that's going on Twitter with a lot of researchers. So I don't really have an opinion at this point. Maybe I'll talk to one of the skeptics and sort of have that conversation with them, if that's the thing you want. So that thing popped up again. So my guess is it's the recording, Chad. So we may not be able to use the recording of the OBS unless I upgrade my computer, because I'm running 64 gigs of RAM, but I don't have I've got a pretty good video card, but I don't have the best processor, and that's probably what's crunching it, is the encoding of it. Okay, well, I'll keep an eye out for that pop-up to come up again. Okay, so Icean moons. Yeah, I know. So I'll keep an eye on it if the pop-up comes up, and Chad can cover it with B-roll. All right, let's do this. Ken and Lucas, what do you think of AI systems like GPT-3? So as you probably know, my background is in computer science, and so I watch all of the developments in computers and artificial intelligence quite closely, and I'm a gigantic fan of GPT-3. I've got an account with GPT-3. I applied because I wanted to try and see if we could use GPT-3 as a way to summarize journal articles in a way that we could make them more accessible. It didn't work great. Maybe if I spent a lot of time working with it, then we could probably make something that's useful, but I wasn't able to sort of get very far with it. There's a new competitor called A21 Jurassic that I've been playing around with. And then the one that I'm really excited about is this program called Dolly, which will draw pictures based on like what you type in. And so the examples are a chair shaped like an avocado and other things like that. So right now they're like a dumb parrot, and even GPT-3, you can just tell that it's not very smart. It's kind of impressive in the way that a parrot can be impressive when it is singing a song or repeating what you're saying, but it doesn't really understand what it's doing. And it's the same thing with GPT-3. It's fancy autocorrect. But what I really like is the way you interact with it. Like up until this point, if you want to do computer programming, you have to tell the computer explicitly exactly what you want it to do. And now it feels like we're going into this world where you can describe in rough terms, you can provide prompts, you can script your prompts in different ways to get the program to produce kind of unexpected results. And the thing that I've found it the most useful for is sort of as a partner to help me write, to help get some creative ideas. And so I will say, write the introduction for something that I'm working on, feed it into GPT-3, see what it sends me back as how it would continue my article. And then that may give me some ideas on other stuff to include and expand upon. There's no way you can trust it today to write anything that's of any value, unless you're just trying to get away with web spam. But I can absolutely see a future, and I don't think it's going to be that long. When right now GPT-3 has 175 billion parameters. People are going to work on a trillion parameter, multi-trillion parameter. There will come this time in the next couple of years, I think, where you will be able to get these tools to write stuff that's fairly comprehensive, fairly cogent, and very useful. And then you're also going to be able to have it draw pictures. You're going to be able to draw figures, be able to come up with graphs and data visualizations, kind of like Iron Man, right? And then eventually start to create, longer, more useful audio, video, text, things like that. So I think what you're seeing is the first step of really an entirely new art form. And of course, the way it always works in the beginning is it sucks, but give it time, especially as technology is increasing at this accelerating rate. And I'm sure within the next 5 years, less, you're going to be depending on these kinds of things all day, every day. There it is right now. I wonder if it's because it's full screen? Okay. Aolol asking about the cosmological axis of evil. I don't really have any opinions about it. Sort of beyond my pay grade. Okay. Sierra Vortec. Question. I hear a lot about the ISS showing a lot of wear and tear. I would have thought something floating around in nothingness or close to it would last forever. Yeah, the evidence seems to be building that the International Space Station is showing its age. It is old. At this point, it's 20 years plus, and some of the modules are older than other modules. And I understand it feels like the thing is just sitting there out in the middle of space. It's not getting rained on. It's not experiencing vast, I don't know. It's not getting snow on it. It's not in the dirt. But it is experiencing all kinds of environmental issues. Think about it. Every 90 minutes, it goes from sunlight to darkness. And so the temperature is changing by hundreds of degrees. And that's got to have an effect across the entire station, with all the metals contracting and expanding with each cycle that's going on. The thing is a machine, right? All of these pumps and hydraulics and filters and all this stuff happening inside the station, and these things are breaking down all the time. And in fact, the astronauts have to spend more and more time on every one of their missions to keep the various parts of the International Space Station in proper operation. And then you've also got the constant bombardment by micrometeorites. So it is getting rained on, but it's getting rained on by chunks of rock and space debris going tens of thousands of kilometers per hour, wearing it down like sandpaper. And so you can see on some of the solar panels, you can see cracks and chips, and like it's being just pummeled by this stuff. And so really, there is a lifetime that the space station is going to last. And I think part of the whole point of launching the International Space Station is to understand what wears down, what requires more maintenance, what goes first, so that we can build longer lasting existence in space. If we want to build the giant O'Neill cylinder that will have hundreds of thousands of people living in it for decades, it's got to be built to last. And so by running the International Space Station, seeing what breaks, that tells you which parts need to be repaired. But it also just really shows you that living in space is not going to be just this really simple, go to space, you're floating around, you're enjoying your time. You are actually in this very hostile environment inside a completely closed ecosystem, a machine that is keeping you alive. And any part of it could break down, and many of those breakdowns could be life-threatening to the astronauts involved. So there will come a time when the maintenance that's required to keep the space station running is just not worth it, and they will deorbit it. And that will be the right move, because it's too unsafe. It's sort of the same kind of math that they did with the space shuttle, although in the space shuttle, just the actual design of it had some safety issues as well. But this is the future of the space station, and it won't be too long either. We're probably into its last decade at this point. Did we cure the problem of the cables being chewed? Yeah. We put a lot of spray foam into the exterior of the trailer, and we found they were climbing up. We had one of the support stands for the trailer. They were climbing up, so I just removed that support stand away from the trailer. So now we're only supported by 3 corners, but they aren't able to climb up any of the others, and so we don't see the mice anymore, which is great, because that was That was getting tough. Can you hear the rain? Yeah. All right. Larry Beckham. You must have seen Foundation now. What do you think? Chad, have we decided if we're going to keep the... Yeah, we'll keep this one in. All right. Larry Beckham. You must have seen Foundation now. What do you think? I loved it so far. I've seen 2 episodes of Foundation now. This is the series that's on Apple TV, and they're fantastic. The world building is great. The graphics are great. All of the characters, the technology is great. I really like. I've mentioned this many times that I would say of all, like, people always ask me what my favorite science fiction series is, and I would say it's Foundation. And I went back and reread the Foundations, and they don't entirely hold up. But the idea of just this long length of time, this idea of thinking about civilization, a future civilization over a vast period of time, and thinking about the rise and fall of that civilization it just really tickled a part of my brain. And so reading the books, coming back to the books, you could see the limitations of Asimov's thinking and experience back in the 1950s when he was writing these. And so they've captured that quite well. Like, the technology feels like 1950s technology, and yet very, very futuristic. Like, you don't have people beep booping on computers the way they do in, say, Star Trek or things like that, where they're just trying to take our current technology and extend it. Like, they've really kind of reimagined how various technologies work, and I really like it. They've definitely added a lot of characterization to the story. We'll see how well that plays out, because in Foundation there were no characters. There were just set pieces to get across points. The character was Foundation. The character was the timeline of the Empire. And so I don't know whether I would have preferred if they really rigorously stuck to the books and didn't try to add a pile of character to it and just followed the timeline of the books, 1 episode per book, per chapter in Foundation, like when he did them as short stories. And so it'll be interesting. Anyway, I'm rambling. I'm really enjoying it. If you are into sci-fi at all, you should definitely watch it. I hope it all pays off in the end. I'm waiting to be disappointed at some point. Drix Slavic. Hey, Fraser, are you a big ripper or a big cruncher? Okay, a big ripper. All right. Durij Slavic. Hey, Fraser, are you a big ripper or a big cruncher? I am neither. All right, so you're talking about the way the universe ends and the multiple ways that things could wrap things up. In the olden days, say back in the 1980s, astronomers weren't sure how the universe was going to end. And so they performed a bunch of really detailed experiments to measure the shape of the topology of the universe. They're trying to figure out whether or not the universe was going to continue expanding forever, or whether the universe was going to continue expanding, but it would essentially come to a stop at an infinite amount of time. And then, or it would expand for a while, and then it would reach its limit, and then the mutual gravity of everything in the universe would pull it back together, and it would turn into a big crunch. And what they found was that the middle path was the right one, that the universe would expand, it would reach, like, everything would stop at infinity, after infinite time. And so it would just continue expanding forever, but it was just going to get slower and slower as it expanded. But then in the late 1990s, astronomers discovered this concept of dark energy. And dark energy says that, in fact, not only is the expansion of the universe happening, it's actually accelerating. And so not coasting to a stop, it's going to keep going faster and faster, expanding, things are going to get farther and farther apart, faster and faster. And from that, then, what you get is this future universe that everything is getting farther apart from each other. All the stars in the galaxy get used up. Everything falls into black holes or doesn't fall into black holes. Everything is dead. Maybe the protons themselves decay, the black holes decay. You're just left with this cooling down universe where everything just ends up the same temperature, the background temperature of the universe. And they call that the heat death of the universe, which sounds like everything is getting cooked, but the reality is that everything is just cooling down to nearly to absolute zero, the death of heat. And the one alternative version of that heat death, of that, all the time, right? You've got the dark energies pushing and expanding the universe. And so the one possibility is that the rate that dark energy is changing the expansion of the universe could increase over time. And so we could see a point where right now galaxy clusters are being carried away from each other. But maybe in the future, galaxies will be carried away from each other. And then maybe the galaxy itself, the stars will be carried away from each other. And then the planets, and then atoms, and eventually black holes. And so just things will be ripped apart at an atomic level. And this is this idea of the Big Rip. So right now, it's too early to know if the Big Rip is going to happen. There are some new surveys. There's the Dark Energy Survey. There's Nancy Grace Roman is going to be doing some of this work, trying to measure dark energy. And astronomers want to find out, has the amount of dark energy that's been going on in the universe been constant over the history of the universe? And if it has, then the heat death is the eventual outcome. But if the rate of dark energy is increasing, then you get the Big Rip. So I think the big crunch, the one where everything comes back together, that's off the table at this point. You've not only got the fact that the universe is still going to coast forever, but dark energy is accelerating its expansion. And so it really comes down to heat death or Big Rip. And the Big Rip, I mean, obviously all these things are going to happen billions of years into the future. I won't be around for it. Well, maybe I will, robot bodies and all. But still, we don't have any way to tell the difference. But the Big Rip sounds kind of scary and sad. So my hope is on the heat death. Go heat death. Okay. Glenn Stucklasa. This again. Glenn Stucklasa. Hey Fraser, I'm excited about the new James Webb Telescope. When is it finally going to be online and sending back data? Also, what will it be able to do that Hubble and Co can't? Right now, James Webb is going to be launching in late December 2021. So this year still. Once it does launch, though, you're looking at about a month of the telescope unfolding itself, getting into its final location, going through all of its initial testing. So we won't see that first light image from James Webb until January, February of 2022. Now, what can James Webb do? I mean, James Webb is ridiculously more powerful than the Hubble Space Telescope for a very specific purpose. It's an infrared telescope. While Hubble can do near infrared, it can do visible light, and it can do ultraviolet, James Webb is purely in the infrared spectrum. It can look much more into the infrared than Hubble can, but also look in some of the same parts that Hubble can. And it's a 6.1 meter telescope, while Hubble is like 2.6 meters. So it's like 6 Hubble Space Telescopes, 7, all aligned in a hexagonal shape. So it's really powerful. And so like the main thing that James Webb is going to be able to do is to be able to look all the way out to the very edge of the observable universe, pretty much, to see when the first galaxies were coming together, when you've got all of these small little sub-galaxies that are forming like building blocks into bigger and bigger objects. And right now, James Webb, or Hubble, every now and then gets a glance at one of these galaxies because it uses a gravitational lens. It essentially uses the gravity of a foreground object to act as a natural lens to see a background object, and it can see a galaxy that is like 500 million years after the Big Bang. James Webb will be able to do this directly. Wherever James Webb wants to look, it can see these first building block galaxies. And then, of course, it's going to be able to do a bunch of other stuff. It's going to be able to look at cooler objects here in the solar system. Maybe it'll be able to find Planet 9. It's going to be able to look at and measure the atmospheres of exoplanets. Maybe it'll be able to find out which one. It could theoretically discover life. It could find an atmosphere that has the kind of chemicals going on in the atmosphere that are indicative of life. So James Webb is a really big deal, and astronomers have been pinning their hopes and dreams on this telescope for the better part of 20 years. This is the telescope they wanted next, and it's 10 years late, but it's still the telescope that they want. IVX, have you seen the video Why Go to Space from Joe Scott? I haven't. And I'm his patron. But yeah, I've mentioned this in the past. I try not to watch much of what other people do in this field because I just don't want to get it in my head. So, yeah. So I'm happy to support him, but I tend to not watch this stuff when he's talking about space stuff. Okay. TP Seeker. Perseid meteor showers seem to have been duds for the last few years. Does Earth's orbit have anything to do with why we don't see as many meteors during the Perseids? Meteors can be good or bad for a bunch of reasons. So one of the big reasons why a meteor shower can be bad is it all depends on the moon. Like if you've got a full moon during a meteor shower, it's a bad meteor shower. And if you've got a new moon, that's a better meteor shower. And also, like, the Perseids are not the best of the meteor shower. I would say the Geminids right now are the best meteor shower, the ones with the most meteors. And recently, you can get meteor storms with the Leonids. But the advantage of the Perseids is they occur during August, which for the Northern Hemisphere is a nice warm time of the year that you can lay outside and watch for meteors for hours and hours and not feel super uncomfortable. And that's why they're the most famous. Now, the meteor showers can be better or worse depending on the Earth's orbit. Absolutely, because what causes a meteor shower is the tail of a comet, or in one case, an asteroid. And so every time this comet is coming past the sun and going back out, it's laying a trail of of debris in space behind it. And so each one of these is like a little trail that's carved out in the solar system. And then the Earth's orbit carries it in an intersection through these trails. And so depending on how recently the trail was laid down by the comet, that's how good of a meteor shower or even a meteor storm that you get. The best case scenario is the comet was fairly recent. We passed right through the tail of where the comet was, and then we get a ton of debris coming into the Earth's atmosphere. And then in other cases, we may go a little above it, a little below it, or maybe it's been a long time since the comet was here last, and so there's just not a lot of debris that's left over to enter the atmosphere of the Earth. And so this is why astronomers can actually make predictions about how good they think meteor showers are going to be. They know where the comets were, they know where the Earth's orbit is in relation to these comets, and they know where we're going to be going through these comet tails and whether we're going to have a good one or a bad one. So definitely pay attention when the astronomers tell you, okay, this is going to be a really good Leonids or a really good Geminids, because the positions are really well lined up. And sometimes they just mess it up. Like sometimes they think it's going to be good and then it just doesn't end up being good. And sometimes it's a surprise. So meteor showers can wax and wane depending on all of those conditions. Will the Webb ever leave Earth? Yes. Yes, it's going to leave. Um, let's see. Yes. Is that a globular cluster behind me? Yes. It's a new picture from the Hubble Space Telescope. Science Cyclop, you're asking, what is the mass of Milky Way and Andromeda? I don't know exactly. The Milky Way is like 1 trillion solar masses, and Andromeda is like 1.5, so maybe 2.5 trillion solar masses between the two of them. Jolly Blonde Giant, if we built a particle accelerator on the circumference of Mercury, could it generate enough antimatter to fuel spacecraft? Well, a particle accelerator doesn't generate... I mean, you still have to generate the energy. So are you saying, like, because it's close to the sun, you'd be able to get more solar energy and be able to generate antimatter? I mean, it would be so difficult to set up at the orbit of Mercury. Mercury is like the hardest place to get in the solar system. Well, the sun is the hardest place to get in the solar system. Mercury is the second hardest. And so if you're going to try to get down to Mercury, it actually takes a ton of energy to be able to do that. Better to build a particle accelerator just here on Earth and generate antimatter and then use that. Because like the place you really want antimatter is to try and have a compact energy source that'll get your spacecraft out of the gravity well of the Earth and out into space, and then you can refuel, and then you can use some other method to get around the solar system. So that would be my suggestion. Cryptoman 5000, are we ever going to put a telescope on Mars in the next 10 years? Moon, asteroid? No, I think we may put a telescope on the far side of the moon in the next 10 years. It's probably going to be a radio telescope, but there's no reason to put a telescope on Mars. Like, wouldn't give you a better view to anything, or on an asteroid. Like, in orbit around the Earth is the best place to put a telescope because it's close and you can communicate with it. You can get really good data transmission. Evie Scott and Flower, is any company working on Venusian blimp concepts? No. No, beyond the work that NASA did a few years ago, nobody's taken that idea any farther. Trey Harmon, do you know why Perseverance took 2 samples from the same rock? I don't know. I saw you asked this question a couple of days ago, and I was gonna look into this. And so I know that the first sample that Perseverance grabbed crumbled apart in its hands. And so then they did another sample and this one worked. And I don't know whether it was because maybe someone in the chat can comment on this, but I don't know if it was they did it from the same rock or they did one sample on one rock and they went somewhere else and did a sample on another rock, because so that would explain it. The first sample crumbled into, it's just gone, and so they then had to do a second sample. So I don't know the answer to that one. I'm sorry, but again, maybe someone knows the answer to that. I've put in a request to NASA to get, that's right. So I put a request in with NASA to let me interview someone from the Perseverance sample collection team. So the hope is in the next couple of weeks, I'll have someone here who will answer all of our Perseverance sampling questions, sample return missions. I think the person is the principal investigator for the sample return mission, but also understands what's going on with Perseverance. So stay tuned on that. Perrine. Okay. Oh. Did I kill the question there? Okay, hold on. The second one was from a different rock. Yeah, that's what I thought. So I know the picture you're talking about. there's 2 holes on the same rock. So I wonder if they did that. Oh, now the rain's really falling. Okay. I live in a rainforest. Hey, Fraser, isn't it risky to look at the sun even with a solar telescope? Oh, sorry. Perrine. Hi, Fraser. Isn't it risky to look at the sun even with a solar telescope? Shouldn't we project the image elsewhere first? For starters, yes. Never, ever, ever, ever look at the sun with a telescope, like with your own eyes. You will destroy them instantly. You can light things on fire pointing out the back of a sun. Let me do this again. You can light paper on fire when you project an image of the sun through a telescope. Very bad idea. Never do it. No, no, no. But there are telescopes that are operated by NASA, and there's the Daniel K. Inouye solar telescope on Haleakala that is focusing on the sun. And of course, it seems really dangerous when you've got a 4-meter telescope looking at the sun. And of course, managing all of this is incredibly complicated. So what they do is they block a tremendous amount of the light that's coming from the sun, like 99.99% of that light. And then when the light that they're left with, they split it a bunch of times and then they magnify that, and that's how they're able to take a look at the images on the sun. But your first step is you've got to block that light at the source. And so if you've got a telescope and you want to look at the sun, what you do is you put a solar filter and you put it on the front of your telescope. So before the light from the sun gets into your telescope, you have already knocked it down a significant amount. So you're left with a very, very dim object. And then that can be magnified inside your telescope to allow you to be able to see the features on the sun. And it wouldn't be possible if you didn't do that. And so with, say, the more powerful telescopes out there, a lot of their issue is the heat management. The thing is facing at the sun, it's gathering an enormous amount of heat, and they have to be able to mitigate all of that heat within the observatory and get it pumped out. And so that's a lot of the big challenge, is that your telescope doesn't overheat because you're looking at the sun. But they've been able to figure out how to do this scientifically, engineering feat, and so we can get these incredible images of the sun without destroying the telescope itself. Is your house? Someone asked me about my house completion. Where was it here? Oh yeah. What's your house status? Completion, where 100% is you can move in, like a building sim game. We got approval from the Comox Valley Regional District to be able to build our house. So now we're allowed to start. We've got a hole, we've got a bunch of building supplies, and we had like monsoon heavy rains in the last couple of days, which filled the build site with a ton of water. And so we've had to mitigate that water and trench a bunch of stuff. And so we're going to bring in a bunch of new gravel in the next couple of days to try to be able to support the foundation and then start pouring the foundation. So we haven't started, but again, in theory, it's a relatively simple build. And so hopefully in the next 3-4 months, but we're already finished September, we're getting into October. Could very well be that we're going to have to stop once the snow appears. So we'll see what happens. I'm hoping I'm not living in this trailer for a year. Ken Lucas is asking, why is ULA going to stop using Atlas rockets? Bezos doesn't deliver the engines for the Vulcan part. I mean, ULA is stopping using the Atlas and the Delta, Boeing's with the Delta. Anyway, they're stopping using these rockets because they're just not competitive with SpaceX anymore. And so their plan is to have something that's more reusable with the Vulcan, and they were going to use the Blue Origin BE4 engines. But they haven't materialized in the way they were hoping, and so they're sort of stuck in between a rock and a hard place right now. I'm not sure. I would love to talk to Tori Bruno about what the future holds for ULA in the current situation. I'll ask him again because he said he would come on and talk with me, do an interview with me. So I'll nag him again and see if we can talk about this because I got a ton of questions. I mean, I would rather talk to Tori Bruno, I think, than Elon Musk. Yeah, I'm interested, and I'd love to talk to Jeff Bezos just sort of about like I want to hear somebody come up with a cogent response, competitive response to SpaceX. I don't want SpaceX to run away with the whole thing. I think competition is a good thing for everybody. Whoa. BK Nessheim, does the Earth lose weight or gain as a total of what is falling in and gas escaping? I used to know these numbers. They were in my head, and so I would be able to answer this really well. But I think they're roughly the same. So we get a few thousand tons of debris from space landing on the Earth every year, and a similar amount of gas escaping from the Earth. So over time, we're getting less atmosphere and more dirt, but not anything that's significant that would have any effect on the Earth over a long period of time. But I forget the exact numbers, so I apologize. Sierra Vortex, can you explain why the sun is so difficult to get to? You'd think the biggest thing with the most gravity would be the easier because it's getting a bit warm. Sure. I answered one of your questions, so I'll just do this one quickly. So right now, the Earth is in orbit around the sun, and we're going 30 kilometers per second. And so if you just aim your spacecraft at the sun and you fire your rocket, you're just going to end up in a different orbit around the sun. The only way to actually fall into the sun is to cancel out that 30 kilometers per second of velocity that the Earth has in going around. And so if the first thing you have to do is you have to launch a rocket from the surface of the Earth. So you've got to go like 11 kilometers per second to go into Earth orbit. So you've used up a ton of your propellant to be able to just get into Earth orbit. And then you've got to fire your rocket and get another 30 kilometers per second of velocity change to be able to cancel that. And if you could, then you would just fall directly down into the sun. But if you don't, then you're going to be in orbit around the sun, just in a different orbit than the Earth's orbit. And so that's why it's actually really hard. And so in order to get down to Mercury, spacecraft have to do slingshots, these gravitational slingshots around Venus, around Earth, even around Mercury, each time essentially speeding up the planet. It's like the opposite of the gravitational slingshots that they do when they're trying to go out into the outer solar system, where they slow down Jupiter and get a tiny little speed boost, or they get a giant speed boost. They slow down Jupiter a tiny amount and get a big speed boost. When you fall in, it's backwards. You are speeding up Earth a tiny little bit, or speeding up Venus a tiny little bit, and you are slowing down your velocity and putting yourself into a better orbit to get closer and closer. And after multiple of these flybys, you can make it down to, say, the orbit of Mercury. I think the Parker Solar Probe has to do 11, some enormous number of flybys of the various planets to be able to get really close to the sun. So that's why it's so fast. So Matter Hat asked that. So Chad, do you want to use that then? Because I know Sierra Vorta, I think I answered one of your questions as well. So I'll give the name and then you can give the answer. Matter Hat, why is it harder to go down the gravity well to the sun? And then use the answer I just did. Michael Booth, getting stuff and people home from Mars. How do we do that? Is it just as easy as getting there? Okay, I'll do that one. Michael Booth, getting stuff and people home from Mars. How do we do that? Is it just as easy as getting there? No. Getting stuff back from Mars is going to require us mastering this in situ resource utilization that I mentioned. We're going to have to be able to make the rocket fuel on Mars. So the spacecraft, say Starship, it's going to launch from Earth, it's going to refuel in Earth orbit a few times, and then it's going to fly to Mars, land on Mars, send all the Marsstronauts out onto the surface, and then it's going to be hooked up to some kind of reactor on Mars that is going to be turning carbon dioxide and water into methane fuel locally. And all it requires is those raw resources. It's a very well-known chemical process and has been demonstrated many times here on Earth. There's no reason to think why it wouldn't work on Mars as well. And then over long periods of time, it will fill up its tanks on the surface of Mars, and then it'll be able to lift off and fly back to Earth. Of course, the gravity well on Mars is a lot lower, so it doesn't require as much fuel as it does to get out of the gravity well of Earth. And so once we've mastered that technology of being able to generate rocket fuel on Mars, then we'll be able to bring people home. And in fact, when NASA does its sample return mission, so right now, Perseverance and the future European Space Agency rover are going to be collecting samples. They're going to be returned to Earth with a Mars sample return mission. And that's probably where we're going to see this technology tested out first. The rocket's going to land on Mars empty, and then it's going to generate its fuel on the surface of Mars. The samples will arrive, and it's going to lift off from Mars and come back to Earth. There's more steps, but generally that's what's going to happen. And so we'll find out whether or not this system works at all. And then later on, if you want to be one of the colonists who goes to Mars, you'll be able to go to Mars. And then when a rocket is coming back home, it'll be refueled. You'll be able to get on and return to Earth. Okay, I'm going to wrap there. I'm going to do the Patreon bumper, the outro, and then I will stick around and we'll do some bonus time. More questions in a second, but first I'd like to thank our patrons: Helga Bjorkog, The Giant Nothing, Jordan Young, Viva Tomlin, Bob Harkins, and the rest of our 805 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right, those were the questions this week. Thank you, everybody who asked them either beforehand or during the live show itself. Again, I need more questions. So if any of the ideas that we talk about here or with any of the interviews or episodes that we do, or if just anything in the news gives you a question, go ahead, just type it in on any one of my shows and I will gather a bunch of them up and I will answer them here. All right, I'll see you next week. Okay, all right, let me just it's going to shut the recording down. That one. Oh, I can hear my processor's getting happier. My shoulder keeps disappearing. Green screen problems. Okay. Don't go. I'm not going to go, Chatty Walrus. I'm going to. I just needed to stop the recording. Oh, you posted like 7 questions. We'll do them. Avi Scott and Flower, would a telescope 1,000 times as powerful as James Webb be able to see what happened before the Big Bang? No. But I feel like we've answered this before. But anyway, no. you can only see to the cosmic microwave background and not before. I mean, the limit is not the power of the telescope. The limit is literally the beginning of the universe, that there was no light before. There was nothing you could see before the beginning of the universe. So that's the limit. The hard limit of what you can see in the universe is the beginning of the universe. And then some of the other questions, I don't know. So you're asking about why Elon won't move the launches to the C platform already. I think they're just step by step. I think at this point, the goal is, can they launch orbital? Can they return? Can they land safely? They're going to land in the ocean, and that's sort of the safest version of everything. And then as they get more operational, they'll move to what the final configuration is going to be. But I think it's easier and safer to just launch off of the land. I'd be surprised. It'll take a while before they actually move to launching from the ocean. And you're asking about the 4 components of the propellant consumables. Can they be made or collected in situ in book? Sure. I mean, in theory, you can make methane fuel out of the Earth's atmosphere with electricity. It's just not that convenient. It's more convenient to just buy your methane from a provider and you have them pump it into a tank and then you use it. But we talked about what it'll be on Mars. Science Cyclops. Would a 10-year-old make a good science YouTuber? Sure. Absolutely. Yeah, like, if that's a thing that you enjoy, then do it. Get into it. Like, if YouTube existed when I was 10, I mean, I think that at 10 you're still learning. So I think it would be fun to sort of show you learning the things that you're learning, if that makes any sense, and then bring people along with you what you're doing, as opposed to necessarily being an authoritative expert. Like bring on guests. Like, you could talk to a NASA scientist. They'd love it if you talked to a NASA scientist on your YouTube channel and had a bunch of questions for them. I think it'd be awesome to see a 10-year-old's curiosity about the universe or science in general, and you get an expert to actually talk to them. I think it'd be great. So yeah, I mean, we'll find out if you can do it, but do it. Try it. It'd be fun. What do you have to lose? I love it. Romulus XC, do you think people will be born on Mars, or will just be Science Research Center? We don't know if people can be born on Mars. We don't know if it's safe for human beings to be born on Mars. If it is safe, then yes, they will be born on Mars. If it's not safe, then yes, they will be born on Mars, and it will be a horrible mistake. Yeah, at 10 you're still learning. At 16 you know everything. Yeah, good point. Yeah, the older you get, the more you realize how little you actually know. Luke B. Fraser, do you poo-poo the efficacy of the EM drive? Yeah, I am definitely in the poo-poo camp. There's some pretty recent tests by some German researchers that were able to figure out exactly where the mysterious thrust was coming from the EM drive. At this point, it is absolutely debunked. Wah wah. Keith Kuhn, is there any way to increase the mass of Mars? Sure, you could increase the mass of Mars, but not by much. Like, if you took all of the asteroids in the asteroid belt, you would have an object that was like 1/5 the mass of the moon, or maybe like 1%. No, sorry, 1% the mass of the moon. That's right. So if you took all of the asteroids in the asteroid belt, you have 1% the mass of the moon. And if you took all of the Trojans around Jupiter, you have another 1% the mass of the moon. And maybe if you gathered all of the moons of Jupiter, all the moons of Saturn, maybe through Mercury as well, you could make another planet the mass of the Earth. But we have one. We have Venus, which roughly has the mass of the Earth. So It's some pretty serious solar system engineering at this point. Cryptoman 5000, how long before Starship's first orbital flight in space? All right. I think we will see an orbital flight at end of November. I think it's going to come fairly soon. And I think it will fail. Like, I think it will just burn up in the atmosphere, which is fine. I mean, that's how you test. ATL 530. If Starship is cheaper to catch, what it would look like for the same with airplanes and airports? That's a good question. You could absolutely imagine a system that accelerates airplanes and then catches them as they land. So they don't need landing gear. But I mean, landing gear of a airplane is not a significant fraction of the mass of the airplane, so it makes sense to give an airplane that capability. While with a rocket is like 95% fuel. If you can do anything to get rid of the dry mass of the rocket, then you're going to make a serious improvement to it, which is why they're doing it with a rocket. Imagine a spaceport that launches and lands starships. Yeah, that'd be great. Miguel Angel Romero, it blows my mind hearing you talk about your current house. I imagine you're in your trailer in the middle of nowhere. Is it possible to see a photo or a video of it? Yeah, it is a trailer in the middle of nowhere. I mean, it is just it's not in the middle of nowhere. It's sort of a trailer in the middle of an open field. So just imagine a trailer sitting in an open field, and nearby there is a hole in the ground where a house is going to get built. Actually, a hole in the ground where a shop studio is going to get built. And then after that, a house is going to get built. But yeah, once we've built some of the stuff, I'm sure I'll share some pictures of it. Is this the dude that eats cheese live? No, I don't eat cheese live. Did somebody eat cheese? No, that's Paul. Paul is the dude that eats cheese live. Yeah, Paul Metzetter. So I'm Fraser. It's like, that's like such a weird thing. And I'm like, oh, actually, that makes completely rational sense, what you just said. All right, I'm going to do one more question, and then I will duck out. Lazy Beach Bum, do black holes go down to Planck space? We don't know what goes on inside the event horizon of a black hole. So we know that, the event horizon is a place. It's not like a thing that exists, but it is a point where essentially the escape velocity of the black hole exceeds the speed of light. And so outside of the event horizon, if you're going less than the speed of light, you can escape. Inside the event horizon, you can't. And so inside there, all of the mass of the black hole is compacted in some way. But we don't know whether it is a ball that is a certain size, like maybe it's a kilometer across, or whether it is microscopic, or whether it's, as you say, down to the Planck scale. It could be, just this incredibly, it could be you can imagine like a black hole is like accelerating its compaction, going faster and faster and faster until it is getting smaller at the speed of light. And maybe it goes beyond the Planck scale. We don't know. So it's one of those weird questions. There's a place that we don't know what's going on. We may never know what's going on. There may be no way for us to discover what is inside of the event horizon of a black hole, which is kind of frustrating because we want to know. But yeah. All right. So thanks everyone for hanging out again on this Monday, on this rainy Monday. I hope you're all having a great time. And like I said, we've got two. So Astronomy Cast starts on Friday. So in case you're wondering where that was, the weekly Space Hangout starts next Wednesday. I've got two interviews next week. One with the astronomer that is working on this Hycean model, these hydrogen-rich ocean worlds, and then an engineer from NASA talking about a a rover for Enceladus. So we'll be talking about that as well. So that'll be next week. All right. Thanks, everyone. And we'll see you all next week.